210.
Hello, welcome. My name is Brenden. My name is Brenden. Welcome to the stream. Thanks for dropping by. If it's your first time, then welcome first timer. Let me just check. There we go. Got the pad all set up, ready to go. I think we're good here. Ready for another episode of Cracking the Coding Interview with Rust. We are practicing our coding interview problems, skills, and learning Rust. Rust is a hip, new programming language. It's pretty cool. It's what I'm interested in these days. Trying to learn it, learn all the things, consume all the information about it, try to become an expert as best as I can. So that's what we're doing on this stream. If you are a first-time viewer joining us for the first time, then welcome for the first time. I'm trying to fix my monitor here. The YouTube app on iOS is not very good. It's kind of janky. Doesn't seem to work right. But anyway, making it work. So yesterday, let's see, we've been working on chapter 8. There are only 3 problems left in this chapter. Hopefully I can get through all of them, and then we'd be moving on to chapter 9. 3 problems to go, 8 queens, stack of boxes, and Boolean evaluation. These are the remaining problems. Been a little sick the past few days, so recovering. Really excited about getting back to work tomorrow, Monday. And yeah, that's that. So let's get into it. So if you're joining me on the live stream, hello, welcome. If it's your first time, then thanks for popping in. If you are returning from a previous episode, then thanks for dropping by. So if you'd like to follow along the code for this, everything is all up on GitHub. You can go to my name, Brenden Matthews, no vowels, / cracking the coding interview Rust on GitHub, and you can find the whole project there. It's all there. All the problems, all the past videos, everything I've done up until now. You can check it out, follow along. You can clone the repo if you want and work on the problems yourself, or if you want to go back and do some of the old problems, or whatever. Do whatever you want to do, I guess. And there it is. It's all there. So let's see where we are. Let's go to the book and let's read the next problem. Let's jump into it. Let's get right in there. Okay, problem 12, chapter 8, problem 12. It is called 8 Queens. It says, write an algorithm to print all ways of arranging 8 queens in an 8x8 chessboard so that none of them share the same row, column, or diagonal. In this case, diagonal means all diagonals, not just the 2 that bisect the board. Okay, let me think about this for a minute. So, write an algorithm to print all the ways of arranging 8 queens on an 8x8 board. I suppose that, so I guess this is assuming, yeah, row, column, or diagonal. So this is assuming, this would be so that, like the way I'm thinking about this is, and keep in mind, I don't I'm not really a chess expert or player or anything, but I do know the rules of chess. I think most of the rules. I've played chess. Not particularly good at it, but let's see. Presumably, what needs to happen here is you have to place a queen. Place like one queen at a time. Until the whole board is basically full, or you've used all 8 queens. So let's draw this out. Let's go to the pad. Let's go to the drawing pad. Let's see. What would this look like? Okay. So we got a notebook here. Let's just change the grid here. Wonder if there's an 8x8. No. We'll just go with line grid. Good enough. Okay. So let's think about this. My cables are tangled. Uh-oh. I'm gonna have to unplug this for a second. Please bear with me. One moment. Got a cable mess. Tangled cables. Gonna unplug these guys. Plug it back in over here. And okay. I think we're good now. Is this working? Not quite. One moment. There we go. Oh. Activated. I think we're good. So, all right, so let's draw an 8x8 board. Approximately like this. It's not quite a square. I think that's about a square. Make that one a straight line, please. Man, I don't understand why it fixes my lines sometimes and other times does not. I don't know if anyone else uses this paper app, but all right. Good enough. Sometimes it does what I want, other times it does not. Okay. See there? That worked. All right, 8x8. It's 1, 2, 3. I don't know if I have enough space here. 1, 2, 3, 4. Let's do this. Let's do this. So that's 1, 2, 3, 4, 5, 6, 7, 8. All right, that's 8 one way. Whoops. This board doesn't look very good. Oh man, I keep messing these up. Messing up the lines. Close enough. All right, I think that's 8x8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. There we go. An 8x8 board. Yeah? Let's clean up this corner. All right, good enough. Okay, so let's run through the algorithm here. So I'm just going to draw a little circle to represent the queen. So I think the way this algorithm will work is that it would start off by just placing a queen, right? So place a queen here. It's not really what I want. That's not really what I want. Yeah, whatever. Okay, pretend that's a queen, right? So there can't be another queen anywhere here. Can't be another queen anywhere here. And there can't be another queen anywhere this way, right? So the only place that I can place a queen next would be here, right? Paste in a picture of a chessboard. Yeah, I probably could do that, but it would take me a while, so I'm just gonna go with this. All right, so I can place a queen there, and then basically this would repeat. I can place another queen here, I can place another queen here. So that's 4 queens. The next queen I could place would be, so let me just draw some lines on here to show basically everywhere I can't place a queen. So can't place a queen here, I can't place a queen anywhere here, can't place a queen anywhere here, can't place a queen anywhere here, 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 excluding that. What else? Here, 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 and here. Right? So there are only a few spots remaining where I can actually place a queen at this point. So there's a spot here. I can place a queen there. I can place a queen here. I can place a queen. I can place a queen. Yeah, I can place a queen here, and there's a couple more spots in the corner down there, but basically that's it. Okay, so doing this manually is pretty easy. The way the algorithm that I'm doing here is basically to place one queen and then place another queen, and so on and so forth until I run out of queens or run out of spaces, whatever. And every time I place a queen, I would mark off on the board or on the grid all the positions that are no longer available, right? So if you imagine an algorithm, what does the book say? Let me go back to the book for a second here. The book says 8 queens, write an algorithm to print all the ways. So it's asking for an exhaustive search, basically all the possible ways of arranging 8 queens on an 8x8 chessboard so that none of them share the same row, blah, blah, blah. In this case, diagonal means all the diagonals, not just the 2 that bisect the board, right? Okay. So I think the only way to do this, the only way to solve this, or the best, rather, the easiest naive solution is to, yeah, pick these, like basically place a queen in some available position and then like mark all the unavailable positions and then pick the next one and so on and so forth. And then just like repeat that process over and over until all the different combinations have been found, basically. Can you put 2 queens in the second column? The problem is confusing. So no queen can share the same row. Oh, I actually just, in my example here, I just realized I messed this up. That, you can't place one there. That spot's not available. The next spot would have to be down here. This would be the next available. Anyway, yeah. Because with this, with what I have here, basically like this is all off limits, this is off limits, this is off limits, this is off limits, this is off limits. Oh, no, actually I can't put one there because there's a queen. This queen here means I can't use that spot. These are off limits. The only next available spot in this case is, geez. Can I place 8 queens? Can I actually even get 8 queens on this board? That's not available. That's not an option. I wonder if you can actually, like, if this actually has a solution, like if you can actually place all 8. Because there are only 6 on this board, for example. Let me just back up. Go back to where I was. So let's start with this, and then there must be a solution. Otherwise, why would it be in the book? It would be a little strange if the problems couldn't be solved. Okay. Can't use these. Can't use these. Can't use these. Can't use these. Can't use this. Can't use this. Can't use this. Can't use these. Can't use this. Can't use this. Can't use this. What else? Can't use these. Okay, so there's a spot here. Can put a queen there, but then can't use these. Can't use that. Can't use that. Can't use that. There are only 2 open spaces on the board now. Does it say that you have to place all 8 queens? Write an algorithm to print all the ways of arranging 8 queens on an 8x8 chessboard so that none of them share the same row, column, or diagonal. In this case, diagonal means all diagonals, not just the 2 that bisect the board. Am I missing something in this problem? Because it looks like it's not even possible to place 8. Unless I'm just doing this wrong. It could just be that this can't be solved with the way that I've placed these. But like right now this doesn't look like it can be solved. There's only, you know, there's only like a certain number of spots available. If I take that, then it means, you know, those are no longer empty and there are 0 empty spots. All right, I'm gonna look at Wikipedia because I think I might be missing something in the problem here. 8 queens puzzle. Okay. It's the problem of placing 8 chess queens on an 8x8 chessboard so that no queens threaten each other. Thus, the solution requires that no 2 queens share the same row, column, or diagonal. N queens problem. I see. So, I see. Okay, so there are solutions. It's just the one I was finding there is not one of them. Clearly. All right. So regardless, I think I know how to solve this. Looking at the Wikipedia page is enough to tell me that there are solutions, but the one I was trying to do there as an example is not a solution, which is fine. It just means I need to find, I just need to write the algorithm that will find working solutions. But I think the algorithm is basically the same, and it's just like a brute force algorithm basically. All right, let's just do it. So let's copy problem 11, paste problem 12. So let's change the name of this, test 8 queens. And for this board, I'm just going to have a really simple board with a space. Each position of the board will have a space, and it can either be, we'll say, occupied or unoccupied. Unoccupied. Right? Very simple. So then the board is just going to be, so mutable board will just be a vector of spaces on the board, right? And then a vector of vector space unoccupied 8 by 8, right? That's our board. Let's make sure that compiles. Need to implement some traits, clone, put clone and debug in there. There we go. So that compiles. This is our starting point. So let's look at the code here. So let's write a function which I will call, so let's have one that's place queen, yeah, and what place queen will do is put the queen on the board in a position, a queen, right? We'll say mark that space as being occupied, right? So we've got a board, mutable vector, a vector space, and then x usize, y usize, right? Place queen. So this will place a queen on the board. Board x y equals space occupied, yeah? And then need to mark all adjacent rows, columns, diagonals as occupied, right? Maybe we need a third state here, occupied, unoccupied, and then let's say unavailable as unavailable. There we go. Right? All right, so how do we do that?